After landing, one of our first objectives is building a base and energy supply. So we have different options how you can produce power for your base, and that is a solid generator, solar panels, wind turbines, and gas generator, as well as a Stirling engine. In this particular video, we will be talking about solar power generation and how to set up solar panel tracking. So there is four main types of panels in the game: basic solar panels, flat and angled, also their heavy counterpart, and standard solar panels with a single input-output connection and dual variant with separate power connection and data connection. Those solar panels as well have heavy counterpart with a single connection and dual connection. Mainly, I think you will be using standard solar panels, not the basic. Basic solar panels cannot be adjusted. They can lie flat or be angled, and that's all. They also don't have data connection to them. Heavy solar panels you won't be using that much. I think their main benefit is that they can withstand more harsher conditions on the planets like Venus, where you have dust storms, so they can withstand dust storms. You can also use standard solar panels. You just will need to place glass walls around the panels, making glassed room, but this comes with drawback also, because the star will be making this room hotter every day. You can offset it by creating a vacuum in this room, but it won't be habitable at that point. I would recommend you to aim for the standard solar panels from the beginning. They are slightly more expensive in terms of resources than flat panels, but you will be able to rotate them and aim better at the sun. That will also result in better power production. So, as we see right now, sun is almost at the top, and flat panel efficiency is 75-73% and dropping. The same is in this solar panel, but we take a range, we can rotate it. Let's rotate it 90 degrees on the horizontal axis, and then tilt it back like so, maybe 60 degrees. And now efficiency went up to 95%. In the beginning, you will be adjusting those panels manually during the day, but while building more and more solar panels, it will become tedious process, and you won't have enough time to deal with the other stuff like mining, smelting, or expanding your base. So a natural progression is to add solar tracking. That can be done in two ways. So let's dive into solar tracking. As I said, this can be done two ways: with using logic chips from the logic I/O kits, memory kits, math processing kits, as well as you can use an IC chip for that. Firstly, let's explore the logic setup. For that, we will need a daylight sensor from sensors kit, 2 logic readers and 2 batch writers from I/O kit, 2 memory boards from memory kit, and 2 math units from logic processors kit. Also, it is highly recommended to add area power control between your main power line and your logic. Depending on how you set up the sensor, it is also possible to run the whole setup with only one memory chip and one math unit. So, in order to help you locate all the correct devices and set up this whole contraption correctly, you will also need to use a labeler so that you will be able to rename all the memory, logic readers, batch writers and math units as needed. I can show you. This memory chip is named logic memory horizontal and that one is vertical. I have renamed all the batch writers as well, adding horizontal and vertical to their name, and math units are also named logic math vertical, logic math horizontal. As I have already connected and renamed all the boards, let's set up all the logic and see solar tracking in action. To set up those boards, we will need a screwdriver, and firstly let's select our horizontal and vertical readings from the sensor in the logic readers. For the in, we will select our daylight sensor device and we will read variable of horizontal. The second logic reader will also read from daylight sensor and it will read variable vertical. Turn it on and now we have a reading of 170 degrees. And the daylight sensor also says it is 172 degrees vertical and rising. Here we see that the value is the same. Onto the math units. For the math vertical, we will read from logic math vertical on the first input. On the second input, we will read from the logic memory vertical, and output will be add. So we will be adding to, that should be logic reader. Oh, I need to rename the reader as well. Let's fix that issue. Oh, that is a horizontal, and vertical. Okay. So this is vertical math unit and we need to read from the vertical reader. it will read on the value on this unit, and it will add another value from vertical memory unit. Now onto horizontal unit. It's basically the same setup as the vertical unit, but we need to read from logic reader horizontal, and from the logic memory horizontal we will add those two values and turn it on. That works. And lastly, on batch writer, we specifically use batch writer because it can write output value to the group of devices. So logic writer will write only to one device, and batch writer will write to the group of same devices altogether. So as we can see, our solar panels are connected both on the same data network, and with batch writer we are able to write to both of them. Now on the horizontal writer we will select input as logic math horizontal. We will write our output to solar panel dual, and variable will be horizontal. Same for the vertical batch writer, logic math vertical, solar panel dual as an output, and output variable will be vertical. And as we can see, solar panels are rotating, aligning themselves based on the reading from the daylight sensor. As we see right now, those panels aren't quite tracking correctly. So how can we fix it? Fix our horizontal value, as we will need to rotate our panel 90 degrees to the right, so clockwise. Let's add here a value of 100 and remove 10 degrees, so 90 degrees. We will add 90 degrees to vertical position, but now we need to rotate the panels on the horizontal axis in the opposite way, so we can just subtract 90 degrees, basically minus, set it to minus 90, and solar panels should rotate backwards, and all should be working as expected. If you place daylight sensor in a different orientation, you will need to adjust those horizontal and vertical axes by a different value. After adjusting those memory offsets, memory ports on our vertical and horizontal offset, we can see that our solar panels are tracking sun correctly. Their efficiency is almost 100%. Now on to controlling the tracking with IC chip. For this setup to work, we will also need area power control unit, and additionally daylight sensor as well as IC housing and IC10 chip. For this setup to work, we will need to select on our device inputs on the housing our daylight sensor. Let's do it. So on the device 0 we will check our daylight sensor. On the other device inputs we are not making any changes. There will be no device selected for that, because in this setup we will also use a batch write possibility to control all the connected panels altogether. And now the fun part is writing our first program. Let's plop the chip into computer and press edit. Creating a program for the IC10 requires reading and writing from the device that are marked from D0 through D5, as well as reading from devices. You will need to store and retrieve values from registers. You have 16 registers marked from R0 through R15. Now let's begin with programming. In order to avoid possible errors when using devices and registers, we are going to give aliases for them, and we will assign alias sensor to device 0, so D0. Assign alias to vertical and horizontal registers. Alias vertical will be R0, so our first register will hold value of the vertical axis setup, and alias horizontal will be on R1. Next, we also need to define some variables that will hold some other values. We will use define, and we will use name solar panels, and we need to assign a value. This solar panels variable will hold our hash number of solar panels. So let's find our solar panel dual in Stationpedia. Open it, and we have a prefab hash. Paste that number here. Now we also need to define vertical and horizontal offset. Define vertical offset 0 and define horizontal offset 0. Now the actual business end of a program. Let's add start colon that will mark our start of a program loop. Read some data from the sensor into our registers. So basically we need to read vertical and horizontal position of the sun from our sensor. For that we can use our functions, and here is a list of all the functions you can use in your programs, but for that particular case we need to search for the load instruction. We load our vertical register. We can use alias here from our sensor, that's device, and logic type is vertical. Also, you can check which logic types you want to use in Stationpedia. If we check for the sensor, daylight sensor, down here we have all the logic types that we can read or write. So vertical it is. Also, we will need to read horizontal into horizontal register from the sensor device, and logic type horizontal. Those two lines will represent our two logic readers from previous setup. Next step is using our addition operand, add into vertical register value of the vertical register and vertical offset, and save it to the vertical register back. And same step with the horizontal. In the end, we will set batch to the previously defined hash, our final vertical and horizontal values. So set store batch device hash, we have defined it as solar panels. Let's use solar panels. And for the solar panels, let's check our solar panel dual. We can read and write vertical and horizontal logic types, and that's what we need. Let's write to the vertical type, use as a value our vertical register. Now let's repeat same process. Solar panels, now using our horizontal type and using our horizontal register. And those two lines represent the two batch writers as in the first setup. All looks good. We can confirm our program. Press on export to write the program to the IC chip. Let's take it, place it into housing and turn it on. And as we can see, our solar panels are rotating to the position. And basically that's all we needed. But also we face the same issue as previously. Panels don't face towards the sun. In order to fix that, we can edit the same program again, and we need to change the vertical offset and horizontal offset. For that, I will use the same values as in here, in those memory chips. Okay, so for vertical offset it is positive 90 and horizontal offset is negative 90. Let's edit. Vertical offset positive 90 and horizontal is negative 90. Confirm. Take take the chip from the housing, back to the computer, export, and back to the housing. Panels are rotated to their correct position. Let's wait for the sun. Okay, so sun is rising and panels start to produce energy. Okay, this will conclude our solar tracking tutorial. If you have any questions left, write me a comment. If you liked this video, please subscribe and leave a like. Thank you and see you in the next videos.